Assalamualaikum and good morning. Today we are going to present about chemical bonding. So this is our group members. Auni Khaira, Aizatu Adriana, Siti Nur Safia, and I am Sarah Akila. The agenda for this presentation is number 1, Lewis structure of a simple molecule. Number 2, electron pairs, bonding electrons and non-bonding electrons in a molecule. 3, valence shell electron pair repulsion, BSEPR theory. Number 4, polarity of molecules and bonds. And the last one is types of intermolecular forces. Firstly, we are going to talk about Lewis structure of an atom, which is have 3 for single covalent bonds, double covalent bond, and triple covalent bond. For single covalent bonds, it has 2 atoms share 1 pair of electrons, and 1 atom may use more than 1 single bond to fulfill its octet. For double, we had 2 atoms share 2 pairs of electrons, and it has 4 electrons. For triple, we had 2 atoms share 3 pairs of electrons, and it has 6 electrons.
Next, I'm Auni Khaira and I'm going to talk about J.N. Lewis. J.N. Lewis is the one who makes the VSEPR theory, valence share electron pair repulsion. VSEPR theory used to predict the shapes of molecules in 3D. The shape of a molecule is determined by 2 factors. First, number of atoms bonded to the central atom. They also involve bonding electron pairs, BP, and double and triple bonds do not change the general shape. The second one, number of unshared pairs of electrons on the central atom only involve lone pairs, LP, or non-bonding pairs. And LP on the other atoms in the molecule do not affect the shape. Generally, LP has stronger repulsion than BP. So you can see this is the table of 6 molecular shapes. Next, we're going to present our video presentation.
Good morning everyone, I'm Auni Khaira and here I am standing as your host for the show I Can See Your Molecule 2036. Today, molecules from all over the chemistry world will compete to prove why they are special. Our contestants will showcase their molecular geometry, electron pairs and polarity. Let's welcome our first contestant, CO2!
Wait, what else? Native foggy.
Hi everyone, I am carbon dioxide, also known as CO2. Interesting, can you tell us about your structure?
Sure, my central atom is carbon and I have 2 oxygen bonded to me with double bonds. I also have 4 bonding pairs and 0 lone pairs on my central atom.
So, CO2, what is your molecular geometry? Can you show us a bit?
So, my geometry is linear and with a bond angle of 1 degree.
So, CO2, are you a polar?
Although CO bond is polar because oxygen is more electronegative than carbon, my shape is perfectly symmetrical. The dipolar cancel each other out, therefore I am a non-polar molecule.
Excellent! Give CO2 a big round of applause. So, we're going to welcome our next contestant. Thank you, CO2. Please welcome H2O!
Hi everyone, I am water.
Hello, how are you? I am under the water. Please help me.
Water, tell us about your electron pairs.
My central atom is oxygen. I have 2 bonding pairs and 2 lone pairs.
What shape do you have?
According to BSEPR theory, my electron pairs repel each other. Therefore, I have band shape.
Are you polarity?
Because of my band shape, the dipoles do not cancel out. Therefore, I am a polar molecule.
Amazing! No wonder life depends on you. Water? Okay, so we're gonna welcome our next contestant. Thank you, Water.
Thank you, host.
Okay, so we're gonna call our final contestant is
Wait, what is happening? The atmosphere.
Hello, I am ammonia.
Ammonia, what makes you unique?
That's
My central atom is nitrogen. I have 3 bonding pair and 1 lone pair.
What geometry do you have?
My geometry is trigonal pyramidal. I can show you.
Okay.
So this is 3 distribution of electrons. Therefore, I am monomolecule.
Wonderful, ammonia. Thank you, contestant. Thank you. Today we learned that molecular geometry depends on the arrangement of bonding pairs and lone pairs around the central atom. We also learned that molecular shape affects polarity. Now, who is the winner? The winner is chemistry!
As you can see, for Cl2, both chlorine and atom have a same electronegativity, so the electrons are shared equal. Therefore, Cl2 has a non-polar covalent bond. For HCl, chlorine is more electronegativity than hydrogen, so the electrons are shared unequal. Therefore, HCl has a polar covalent bond. Now, let's look at bond polarity and molecular polarity. For CO2, each CO bond is polar, but the molecule is non-polar because the bond dipole cancel out each other. For H2O, OH bond are polar and its band shape. The pole dipoles do not cancel out, so H2O is polar molecule.
In this slide, I'm going to explain intermolecular forces. Intermolecular forces is forces that exists between molecules. It determines whether a sample is gas, liquid or solid, and intermolecular forces are weaker than covalent or ionic bonds.
I'm Aizatul Adriana and I'll be talking about types of intermolecular forces. So there are 4 types of intermolecular forces, which is London dispersion force, dipole-dipole force, hydrogen bonds and ion dipole force. For London dispersion force, it is the weakest intermolecular force. It happens when atoms near one another. Valence electrons of one atom will repel the other and expose positively charged nucleus of the other atom, and occurs in all molecules, particularly between non-polar molecules. For dipole-dipole force, it occurs between polar molecules and one end of partial positive attracts another end of partial negative charge. For hydrogen bonds, it occurs when between polar molecules, specifically between a H atom and a highly electronegative atom, O, N or F from another molecule, and it is a very strong dipole-dipole attraction. For ion dipole force, it attract forces between ion and polar molecule. So we'll be showing you a video presentation based off intermolecular force.
Everyone, emergency, the temperature is going up fast. If we reach the boiling point, this whole fortress will enter into gas. Who is defending us?
Commander, I'm trying my best here, but I'm only a...
What do you mean about that? Explain yourself.
Well, my impression is basically an accident. The electrons move around and suddenly, boom! Temporary dipole, then a second later, gone again. I protect non-polar molecules like Cl2, but honestly, I'm the weakest soldier here.
Besides, your temporary situation can't handle this. Let the professionals work. Commander, deploy dipole defense.
Lieutenant Dipole, can you defend survive the heat?
Absolutely. Unlike London, my attraction is permanent. I work with polar molecules like HBr. I simply match with negative and positives like magnets on the dating app. That's why it takes so much more heat to break my team apart.
Uh-oh, the temperature is still rising. Dipole ship is cracking. We need our strongest fighter.
Did someone call for VIP? Make way. The legend has arrived.
Titan, tell me about the hydrogen bond squad.
Well, you know it. Hydrogen doesn't bond with just anyone. We're exclusive. Only nitrogen, oxygen, and fluorine get VIP access. When we team up, we form the mighty hydrogen bond. Tell water and ammonia to stay strong.
Wait, the enemy is attacking us from water. And I think we should come in.
No problem. Time for my ultimate transformation. Ion dipole force. I connect ion directly to polar molecule. Positive ion grab negative ion. Negative ion grab positive ion. Positive ion. According to the ranking, I'm basically the final boss.
The temperature is stabilizing. The hurricane is walking. We are safe now.
So, we're not turning into a gas?
Not today, soldier. Science wins again.
For the waters of matter, sun shall prevail.
Thank you for watching.